Hello my dear students, welcome back to the session. So let us look at some more important points to be noted in the fundamentals of AC circuit. The fourth one is, last time we have gone up to 3 points, okay? Now this is the fourth point. This is Y1 and Y2. Say this is the overall is Y. So what is Y1 actually? Y1 is say G1 plus JB1. Okay? Y2 is G2 plus JB2. You can also take Y1 at an angle of theta 1, Y2 at an angle of theta 2. Okay. Then Y is equal to what? Y1 plus Y2. Then overall G1 plus G2, or let us say G plus JB, otherwise you can say G plus JB. So Y at an angle of theta. You know that G is equal to G1 plus G2 and B is equal to B1 plus B2. That's it. Clear? Now these two can be added. This is G1 and this is B1. And what is this actually here? Y1. At the tip of Y1, you can take again G2 and this is what B2. So that means one triangle is added at the tip of other triangle. Every complex phasor is a triangle, we can say. Now Y1 is a complex, this is a triangle, this is a triangle. This triangle is added at the tip of this triangle so that you get the total triangle Y. Okay. So here you get G2, nothing but total G. Here you get what? B1, total B. And this is what actually total Y. Clear? So this is theta 1, this is theta 2, this is the overall theta. Clear all of you? Okay. So like this we can note down. Okay. So please note on that. Fifth one. We go with fifth one, another important point to be noted. Quickly note down. Okay, now we can look at the problems, different problems are coming in the exam with respect to even the power supplied or absorbed by the AC source. We also discussed the same power supplied or absorbed by AC source, any source or in the DC source. Okay, we discussed that, right? P is equal to V into I. If current leaves from the positive terminal, then we can call it supplied power. If the current is entering into positive terminal, then we call it absorbed power. Yes or no, all of you? Okay, the same thing we can observe here also. But here, you have the power is nothing but what? There are three powers. Apparent power, active power and reactive power. But we are more focused on the active power because that is the only power which does some useful work. Yes or no? Okay. So here, if I take, say this is a network, and for this network, I have connected a source, let us say. I have connected a source. Say this is V. This arrow placed outside the voltage source indicates this is at higher potential, this is at what? Lower potential. Understand? This is at higher potential, this is at lower potential. That means this is plus, this is minus. So you place either this or plus minus. No need to keep both. Okay, same time. You take plus minus or else this arrow, any of these, but for convenience to make you understand better, I am placing both at a time, but need not to place both at a time. Okay. Now assume that some current is delivered by the source like this. And V is an RMS phasor and I is an RMS phasor, current and voltages. Okay, you can see. Now let us look at what is the complex power of it. S is equal to V into I conjugate. Say V is equal to V at an angle of 0. Okay, or alpha. I is equal to I at an angle of beta. Angle phi is nothing but alpha minus beta. Clear? Angle phi is nothing but what? Alpha minus beta. So now you see Vi cos phi plus j Vi sin phi. Understand all of you? Okay. What is this now? P. What is this now? Q. Now I told you already my concern is P. capital P is equal to VI cos phi. See, in DC circuits, we had just product of voltage and current only. But in AC circuits, we have VI, again power factor. Cos phi is nothing but what? Power factor. Cos phi will decide whether this P is positive or negative. Understand all of you, okay? Now, P will be positive when cos phi is positive. P will be negative when cos phi is negative. Understand all of you? Therefore, angle phi will decide. What is angle phi? The voltage and current of this particular source, the phase difference between these two will decide whether this P is positive or negative. Now, as far as this convention is concerned, current I is leaving from positive, no doubt. Yes or no, all of you? But you also know that if P supplied, let us say supplied is some minus 30 watt plus 30 watt, can be written as what? P absorbed, what is this? Minus 30 watts. Yes or no? Or else P absorbed is minus 60 watt, let us say. P supplied can be written as what? P supplied can be written as what? Plus 60 watt. Yes or no? Okay. So this we already know very well. Now based on this concept, let me find the power of this source. Okay. Let me find the power of this source. And now I understand this current is leaving from positive, that means it is supplying. But let me check whether this P is positive or negative. If it is positive, for this case, current is leaving from positive, I can say this is supplying the power or delivering the power. For the same case, if I find that power is negative, then I can convert into positive. Okay, then I can say absorbed. This is absorbed power. I can say, okay, power supplied is, you got negative, let us say, then power absorbed can be written as what? Power absorbed can be written as a positive value. Understand all of it? Okay. Therefore, here I think power supplied is negative, then power absorbed will be positive. If power absorbed is negative, then power supplied is positive. Clear all of you? Okay. So like this you can see, but it all depends on the value of what? Phi only. It all depends on the value of what? Phi. That means phase difference will decide. Phase difference between voltage phasor and current phasor will decide whether this P is positive or negative. But you know that you take the quadrants here, this is 0. Okay, this is 0. This is 90 degrees. This is 180 degrees. This is 270 degrees. Yes or no? Okay. But you also know that this is minus 270 degrees. Yes or no? This is minus 180 degrees. This is minus 90 degrees. Yes or no? And this is 0 again, or 360 degrees. 0 or 360 degrees. So all silver teacups, that means cosine is positive only in first and fourth quadrant, but its value is negative in second and third quadrant. That means when you find phase difference, phi, angle phi, that is alpha minus beta, if that angle is between, or if it is lying in first and fourth quadrant, then only it is a positive value. In third and second quadrant, if it is lying, then its value is negative. In such case, for this particular case, I can say it is delivering negative power, nothing but absorbing a positive power. Understand all of you? Okay. Delivering negative power, nothing but what? Absorbing positive power. You can indicate like that. So if angle phi is in first and fourth quadrants, that is phi belongs to 0 to 90, 0 to 90, okay, or what is this? Minus 90 to 0, or 0 to 270, or 270 to 0. Yes or no? 270 to 0 or 0 to 90. 270 to 0 is nothing but what? Fourth quadrant. 0 to 90 is nothing but the first quadrant. Then active power or average power, whatever the average power you are calculating or active power you are calculating, capital P, will be positive. Yes or no, all of you? Now it is delivering a positive power. That means the source supplies or delivers positive power, or it absorbs negative power. You always need positive power. Yes or no, all of you? Okay. This is the first important one to be observed. Now second one is what? Look at this, all of you. It's very important. One question came on the same concept. Now, if it's very, very important. If angle phi is in second and third quadrants, that is, angle phi belongs to, it's not or, it is and, okay? And what is this? 90 to 180, right? 90 comma 180 and okay, and 180 comma 270. Okay, if that angle is between 90 and 180 between, or 180 and 270 between. Okay, this is 270 and 360. 0 is nothing but what? 360 only. 0 or 360 both are same. Yes or no? Now you can take then power, average power. What is that average power? Nothing but active power or real power. Now the source, okay, here you can say P average is positive. That indicates the source supplies the positive power. Therefore, here also the average power is negative. That means the source supplies or delivers negative power, negative average power. Here positive average power. Yes or no? That is, the source absorbs positive average power. Clear, all of you? Okay. This is how you need to understand power supplied or absorbed by the energy source based on angle phi. Just based on this concept, there is a problem very recently in the gate asked. Understand, all of you? I'll discuss that problem also by referring this particular case. Okay, so please note down quickly here. Okay, so power supplied or absorbed in DC circuits will end, but in AC circuits, when you apply, cos phi is another factor which is multiplied with V into I. So from that, we need to analyze in a different manner. So angle phi will decide whether this source is supplying the power or absorbing the power. Clear? So please. Right here, the source supplies positive average power, or the source absorbs negative average power. Okay, both are same, right? Supplied negative, absorbed positive, both are same. Absorbed negative, supplied positive is also same. Okay. This concept we already learnt in case of DC circuits. But now we need to remove this part. I can remove this part, right? Because you already written this, right? Okay. You can also note this particular one, that there are two impedances or admittances. Each one is taking the power of P1 plus JQ1, P2 plus JQ2. These are the two powers. So you know that very well. S1 is equal to P1 plus JQ1, S1 at an angle of phi 1. S2 is equal to P2 plus JQ2, S2 at an angle of phi 2. S is equal to P plus JQ, S at an angle of phi. Clear? Now you see S1. What is S1? P1 Q1, right? This is angle phi 1. I can add at the tip of S1 to get S2. Yes or no? This one is going to be P2 Q2. So here you are going to get P2. This is Q1. This total is going to be Q and this total is going to be P. Now power triangles can be added. At the tip of S1, if you add S2 triangle, then you get S triangle, that is yes. Okay, so this is overall P, this is overall Q, this is overall S. S is nothing but P square plus Q square. This angle is going to be phi. Clear? I think you have written this part. Please note down that. Okay. Is it clear? Now let us see some problems. Problems. Let us see some problems. Okay. So let us see some problems here. Problem number 7. Classroom workbook. You can go through that. Problem number 7. If average value, V average value is equal to half of V max, then what is the value of alpha? Some periodic waveform is given. It's a half wave, full wave rectified waveform. Okay. And the full wave rectified waveform given here is, please go through the problem number 7. The problem was given like this. This is a alpha. This is alpha plus pi. This is angle pi. This is 2 pi. This is theta. V max. V of t. Clear? So what is given actually here? V average. Average is equal to half of V max. Then what is alpha is asking. So I told you already that when periodic waveform is given, you are supposed to follow standard procedure. What is t first? T is nothing but pi, 0 to pi, but 0 to alpha and alpha to pi. So let us define it mathematically. What is this alpha actually here? Alpha is a firing angle, not a delay angle. Okay, it is a firing angle. So firing angle, when you have, it is 0 for theta between. This is what theta, okay? 0 to alpha. It is V max sine theta for theta between alpha and pi. So V average, we know the formula, 1 by pi. 0 to alpha, it is 0, then alpha to pi. V max sine theta d theta. So you get 1 by pi minus cos theta V max is alpha to pi. Okay. So substitute there and then simplify, because this value is given as what? V max by 2. This V max and this V max get cancelled. And finally, if you calculate that, okay, then you will get here, actually, what is this value? Minus 1 by pi cos pi minus cos alpha. Understand? So just simplifying this, you will get the value of alpha. I can give you 55.25. Approximately, you will get this angle. Okay, so please note down that. 7th problem it is. Note down. Note down. Next, we'll switch over to 8th problem. We switch over to the 8th problem. What is the 8th problem in the classroom workbook? Just go through that. Let me read that. This question was asked in IES. The ratio of available power from the DC component of a full wave rectified sinusoid to the available power of the rectified sinusoid is. Okay. The ratio of available power from the DC component of a full wave rectified sinusoid. First of all, what is the power? Power is nothing but what? Strictly speaking, the power is nothing but RMS magnitude of the current square into R. This is power. Okay. Strictly speaking, the active power, real power, or power, the average power, true power, all are same. It must be always I square into R. IR square into R, otherwise, let us say, or VR square by R. But what is it saying here specifically is mentioning the ratio of available power from the DC component. Okay, this power, the actual power or effective power is this one only. But from the DC component means what? Average power, right? I mean, the power due to the average value of the current. DC component is nothing but average value. Yes or no? DC component is nothing but what? Average value. So you take now the current RMS, instead RMS, you take average value into square. Now he is asking the power due to the DC component. divided by the effect component. See, sinusoid, I read it. The ratio of available power from the DC component of a full wave rectified sinusoid to the available power of the rectified sinusoid. The available means the total or net or effective. Okay. So what you get here, DC component I average square into R divided by I RMS square into R. They both will get cancelled. But what is I average for a full wave rectified sinusoid? It is how much? 2 I max by pi whole square by I max by root 2. I max by root 2. Okay, whole square. Now what do you get here? I max and I max will get cancelled. This is 2 square, that is nothing but 4, again into 2, that is 8 by, you get pi square. That's it. Note down that. Note down that all of you. We'll see the next problem, 9th one. Okay. 9th one. The average value of a periodic function V of t of the given figure is, this question was also asked in IES. Okay, theta V and this is phi given. This angle up to this part was given phi. Okay, so please go through the question clearly in the classroom workbook, then you will understand it. This is what given. Up to this is 2 pi and so on. So what is asking actually here, the average value of the periodic waveform. First of all, the sinusoidal function. Yes or no, all of you, okay? This is a sinusoidal function, but this function, how you define it? The sinusoidal function you define because it is starting with an advanced angle phi. Yes or no? What is the time period t equal to 2 pi? That means 0 to 2 pi. That means again you have 0 to pi there is signal, pi to 2 pi there is no signal. Yes or no? 0 to pi and pi to 2 pi there is no signal. So I define mathematically here, it is 0 to pi, it is V max sine omega t plus 5. Why I am taking plus 5? Because it starts bit advanced, that is advanced angle is available. Now what is the signal between, this is for theta between what, or omega t between what? Omega t between 0 to pi. But there is no signal for omega t between pi to 2 pi. Yes or no? Therefore, V average will become now. What is V average? 1 by 2 pi, 0 to pi, because there is pi to 2 pi, there is no signal. So V max sine omega t plus 5 d omega t. So 1 by 2 pi, it becomes minus V max cos omega t plus 5 0 to pi. Understand? So you substitute here minus V max by 2 pi cos pi plus phi minus cos 0 plus phi. Understand all of you? Okay. So you can simplify cos pi plus phi is nothing but what? Cos phi. Cos phi minus cos phi and minus cos phi. Yes or no? Okay. That means minus 2 cos phi. Minus into minus plus phi. 2 gets cancelled and finally you are left with V max by pi cos phi. This is your answer. Understand? Okay. So option A is the correct answer in the given 4 options. Quickly note down. 9th question, this one. Note down. Meanwhile, I just remove this part. Question number 10. Question number 10. Read the question. In a series circuit, R is equal to 20 ohm and L is equal to 0.06 Henry. The current lags behind the voltage by 80 degrees. Find omega. Current lags behind the voltage by 80 degrees, lagging. Find omega. He's just asking what is omega, right? So you know that in a series circuit, tan theta will be nothing but XL by nothing but omega L by R. Okay, he's asking omega. So R tan theta by L. Substitute R value 20 tan 80 degrees by L value 0.06. You will get 1890 radian per second. A simple problem it is, okay? 11th problem. Note down that quickly. 11th problem. What is the 11th problem? A series RL circuit has 0.02 Henry, L is equal to 0.02 Henry, and an impedance of 17.85 ohm. And an impedance of 17.85 ohm. The current lags the voltage by 63.4. 11th problem, classroom workbook. Calculate omega and R values. A series RL circuit has L is equal to 0.02 Henry and an impedance of what? 17.85 ohm. And current lags the voltage by 63.4. Lagging power factor angle. Just asking what is omega and what is R. Okay, so Z, L, phi is given. Let's consider the triangle of Z. This is R, this is XL, this is Z. Because current lags is saying lagging, then impedance is R plus JXL form, yes or no? So phi. So what is that? R is equal to Z cos phi. 17.85 into cos 63.4, you will get 8 ohm approximately. XL is nothing but Z sin phi 17.85 sin 63.4. Okay, you will get this XL value, but you must get what? Omega, right? Omega is nothing but 17.85 sin 63.4 divided by XL is nothing but what? Omega L, yes or no? You know L value already given. Find omega, that is 0.02. You can substitute. And finally, the omega value is found to be 798 radian per second. Understand all of you? Okay. This is 11th one. This is also another simple problem. Okay. 12th problem, classroom workbook. Note down quickly. These are all simple problems. Twelfth problem. A series circuit containing two pure elements has V is equal to 200 sine 2000 t plus 50 degrees. I is equal to 4 cos 2000 t plus 13.2 degrees. Okay. So what is the question given? Find the elements comprising the circuit. That means it's asking RL or RC values. But look at this. Looking at this relationship, V and I, can you find whether it's the RL circuit or RC circuit? Yes, we can find. What is the voltage angle? 50. What is the current angle? 13.2. Is it correct? No, you cannot compare because one is sine, the other is cosine. You cannot compare the angles like this. Either both must be sine or both must be cosine. Yes or no? Therefore, let me convert this into 4 sine 2000 t plus 13.2 plus some 90 degrees when you take. Cosine to sine conversion is plus 90. Sine to cosine conversion is minus 90. We learnt already. Cosine to sine plus 90, you remember that. Automatically the other you can easily remember. Okay. So what is actually V? V is nothing but it's a phasor value. Okay. Some people keep by root 2 because they want to deal with RMS values. Nothing wrong in that. Always have a practice. Okay. Now, always remember that whether you want to go for a phasor or RMS value. Now, suppose if I go for phasor, it's only 200 at an angle of 50. If I go for RMS, I must go for what by root 2. So 4 by root 2 RMS representation. What is this? 103.2 degrees. From this, I can write Z is equal to V by I. What do you get here? 50 at an angle of look at this, minus 53.2. Okay. So from this, capital R is equal to horizontal component 50 cos 53.2, then 50 sine 53.2. Therefore, you get 30 minus J40. Z value. Then from this real part is nothing but R. Imaginary part is nothing but 40. But once you get C of XC, but he's asking the elements comprising. Elements means R and C values we require. Okay. So it is very clear it is a capacitive circuit because current leads the voltage by how much? 53.2 degrees. Okay. So it is no doubt from this we can say it's a capacitive circuit. That means two elements are there only in the circuit. RC elements are supposed to be found. R value is known. C value let us find. C is equal to 1 by XC into omega. 1 by what is that XC 40? What is that omega you had? 2000. 12.5 microfarad. Note down quickly all of you. So either you maintain both sines or both cosines. Okay. One is sine, the other is cosine. You can't do the problem. The comparison of the phase angles must be taken place only when both are sine or both are cosine. Understand? Thirteenth one. Now here is one RL series circuit. Some voltmeter readings are given. Some two voltmeters are connected here. If V is equal to 5 volts, that means voltmeter, this voltmeter is reading 5 volts. V2 is equal to 4 volt. Then what is V2? Okay. So in case of DC circuits, it is easy because there is no phase angle concept. But in AC circuits, you have phase angle concepts. Understand all of it? Okay? So if you consult the phasor diagram of this R and L series circuit, you know that very well. This is VR, this is VL. Yes or no? This is I actually. This is VR, this is VL, this is V. And this is what phi. So you know that V is nothing but what VR square plus VL square square root. Therefore, V square is equal to V1 square plus V2 square. From this, you know that V2 is nothing but, okay, 5 square minus 4 square, nothing but 3 volts. So voltmeter reads 3 volts, but only RMS magnitude. See, the voltmeter and ammeters read RMS magnitudes only. Voltmeter. Voltmeter reads RMS magnitude of voltage. Ammeter is the MI type, okay? MI type voltmeter. This is also MI type. Ammeter reads RMS magnitude of current. Understand? Third one is wattmeter. Okay? Wattmeter, dynamo type wattmeter. I think you might have studied in your measurements part. Wattmeter reads average value or real value or real power, average power. Okay? These are all important points to be noted. Noted. 14th problem. 14th problem. It is also in similar lines with 13th problem. Okay? But now I am taking RLC series circuit. Go through that question, all of you. 14th problem. What is the 14th problem? This is V1, V2, V3. This is V, is another voltmeter given. If, what is given here? If V is equal to 13 volts, V1 is equal to 5 volts, V2 is equal to 3 volts, then what is V3 is asking. Sometimes he will also ask you the question, for the given voltmeter readings, how the circuit is behaving, whether it is inductive or capacitive or resistive, or what type of circuit it is. He might be asking the question like that also. Okay? But if you really want to comment on the V3 value or else whether it is inductive, capacitive and so on, definitely you must know the value of voltage across the capacitor. You know that XL greater than XC, nothing but VL greater than VC. Because for a series circuit, XC greater than XL, then VC is greater than VL. So once you find V3 value, that is nothing but voltage across capacitor VC, then you can finalize whether it is inductive or capacitive. And remember, all these are RMS magnitudes only. RMS magnitude, do you have negative value or positive value? Always positive value. So negative value is not feasible. Only positive value is feasible. Getting all of you, because it is reading RMS magnitude, magnitude is always positive value. Getting all of you? Then here, you know that in RLC series circuit, we learnt already V square is equal to VR square plus VL minus, yes or no, all the magnitudes, you can say VL minus VC, okay, whole square. From this, we can write VL minus VC magnitudes is equal to plus or minus root. You take this side and you get what? V square minus VR square. But when you remove this square here, it may be a positive value, it may be a negative value. You have two possibilities, V square minus VR square, square root plus or minus. Then what do you want actually here from this VC? Yes or no? VC is nothing but VL plus or minus or plus, whatever. Both are same. V square minus VR square. Getting all of you? Okay. So you get now from this is very clear. What is VL actually here? 3. 3 minus R plus square root. This is 13. Yes or no? 13 square minus. What is VR? VR is nothing but what? 5 square. So you got 3 minus R plus 12. Look at this. It has two values, right? What are the two values? Minus 9 volt plus 15 volts. Yes or no? 3 minus 12 minus 9, 3 plus 12, 15. But minus 9 is not possible. Only 15 is possible. Therefore, V3 reads 15 volts. That is a magnitude 15 volts. That means VC greater than VL. Yes or no? VC value is 15. What is VL value? Is 3. Therefore, it is behaving like a capacitive circuit. Understand all of you? Okay? No doubt. No doubt. Suppose if you take 14a, I'm just extending the same problem here by taking V is equal to 13 volt. Let us say V1 is equal to 5 volt. Say V2 is equal to some 15 volts. Then how the circuit is going to behave, or else find V3 value. Then what will you get? Tell me, all of you. Same thing, that VC will become now what? VL. What is VL value here? 15. Now 15 minus R plus root 13 square minus 5 square. Now 15 minus R plus 12. So you got two values. 15 minus 12, that is 3 volts. Now 15 plus 12, that is 27 volt. Getting all of you? That means there are two possibilities for voltage V3. That V3 voltage across capacitor will get two possible voltage. There are two possibilities for getting the value of V3 here. That is 3 volts and 27 volts. Now how do you decide? It all depends upon the inductor and capacitor. Now if you want to really call that is an inductive circuit, definitely inductive reactance must be greater than capacitor reactance, or inductive voltage, inductance voltage must be greater than capacitance voltage. So if you take VC 3 volts, it behaves like what? Inductive, because V2, VL is nothing but 15 volts. So if VC is equal to 3 volt, okay, then VL is greater than VC. It behaves like inductive circuit. It behaves like inductive circuit. If VC is equal to 27 volt, then VC will become greater than VL. Then it behaves like what? Capacitor circuit. So in this context, unless we know directly or indirectly, unless we know XL and XC values, we cannot comment or we cannot conclude whether it is inductive, okay, whether it is inductive or capacitive, whether it is inductive or capacitive. Yes or no, all of you? In such cases, definitely XL and XC values must be required. Otherwise, I do not know, because there are two possible values, because both are positive values only. Therefore, both are possible. But whereas in the previous case, one is negative, the other is positive, I can rule out immediately. And there is only one possibility for that VC, that is 15 volt. Then obviously VC is greater than VL. Therefore, I can conclude there. But I cannot conclude in this case. Understand? Read the question in the 15th problem here in the classroom workbook. RLC parallel circuit was given. If V is equal to 10 amperes, V1 is equal to, what are the values given? 6 ampere. Sorry, not V, it is A, right? A, and this is A1. A1 is given as how much? 6 ampere. A2 is given how much? 5 ampere. Then A3 is how much? Okay. So, same procedure. You know that RLC parallel circuit, you have a relation I square is equal to IR square plus IL minus IC whole square. Yes or no? This relation you already have. Then if you take IC again from this, in the previous case also we derived that. So what do you get here? IL, okay. IL minus R plus root I square minus IR square. Clear? So what do you get from this? What is IL? IL is nothing but 5 amperes. So 5 minus R plus root, what is I? 10 square. What is IR? It is 6 square. Okay, so you get 5 minus R plus 8. 10 square minus 6 square is nothing but 8. Yes or no? So you got two values. 5 minus 8 minus 3 ampere. 5 plus 8, 13 amperes. Clear? 5 minus 8 minus 3 amperes, 5 plus 8, 13 amperes. Is it feasible now? It's not feasible. This is only feasible value. That means you got IC, okay? IC is 13 amperes, whereas IL is how much already given? 5 amperes. Since IC greater than IL, that means BC greater than BL. In case of parallel circuit, you know very well, if BC is greater than BL, you can call it capacitive or inductive. You call it capacitive only. Okay, so this is very, very important. Similarly, if I change the values, A2 value something like 12 amperes or 14 amperes, something like that, then you may get two positive values. Look at this. If it is 5 amperes, negative. But if it is, let us say 12 amperes, 12 minus 8, 4 amperes, 12 plus 8, 20 amperes. Now there are two possible values or plausible values, feasible values. Then you cannot conclude whether it is inductive or capacitive unless BL and BC values are given. Clear all of you? Okay, this is very, very important, because in exams, in which dimension is going to ask the question, we do not know, but we must be clear with the concept. Okay, so please note down that quickly. This question was asked in IES, but very simple question. Let me read it. An RLC series circuit has a resistance R of 20 ohm and a current which lags behind the applied voltage by 45 degrees. If the voltage across the inductor is twice the voltage across capacitor, what is the value of inductive reactance? Okay, simple. What is the data given? R is equal to 20 ohm. Okay, and current lags the applied voltage by 45 degrees. That means angle phi is 45 degrees. This is power angle or power factor angle. Both are same. Now, voltage across the inductor is twice the voltage across capacitor he has given, right? Voltage across the inductor is twice the voltage across capacitor. Yes, from this you can say, because it is a series circuit, can I say I into XL, right? I into XL is equal to 2 times I into XC. current is same. Therefore, XL is equal to 2 times XC. Equation 1. Right? Next one is what actually has given angle